I will be explaining number 2b. So a skateboarder starts at 5 meters per second and accelerates down a 10-degree frictionless ramp. At the bottom of the slope, she is going 11 meters per second. What is the length of the ramp and how long does it take her to skate down the ramp? Okay, so it is given to us that her initial velocity is 5 meters per second and that her final velocity at the end of the slope or at the end of the ramp is 11 meters per second, and that the degree that the ramp is at is 10 degrees. And we know that her starting position is not given, so we can assume that it is 0, x initial is 0, and everyone knows that the acceleration in the y direction is negative 9.8 meters per second squared. So those are given values. And so we need to find what the length of the ramp is and how long it takes for the skateboarder to reach the bottom. So, but for this, I'm going to start off by finding how long it takes for the skateboarder to skate down the ramp. And so what I will be doing is, we know that one of the kinematics equation is velocity final is equivalent to velocity initial plus acceleration times time. And velocity final and velocity initial were given to us. So we just plug that in, so we get 11 and 5. And then for acceleration has different components. So there's x and y components for acceleration, especially since this is an inclined plane. It isn't directly horizontal or directly vertical, so there will be x and y components. And so the the components for the components involve the degree. And as you can see here, that's theta, which is 10 degrees, and that theta is also equivalent to over here, which we make the x and y components of acceleration. And so we know that the y component for acceleration, including theta, would be g cosine of theta, as cosine is adjacent over hypotenuse, and this is adjacent over hypotenuse. And we know sine is opposite over hypotenuse. So at the bottom of the triangle, that would be sine g sine theta, which that's the x component of acceleration. It would be g sine theta. So knowing that information, since the bottom of the triangle is parallel to the skateboarder going down the ramp, we would be using g sine of theta for acceleration. And so we'd plug that in, g sine of theta, and times time, as according to the kinematic equation, and we would get 11 is equal to 5 plus 9.8 sine of theta, which is the x component of acceleration going down the ramp component, times time. We get 6 is equivalent to 9.8 sine of 10 degrees times time, and we get time is equivalent to 3.5 seconds. So it takes her 3.5 seconds to get from where she is from the x initial to the bottom of the ramp. And we can use the information to calculate what the length of the ramp is. In physics, we are given this kinematics equation: x final is equivalent to x initial plus velocity initial times time plus 1/2 acceleration times time squared. And using that and the time value that we figured out, and the given values, we can calculate how long the length of the ramp is. So x final is the bottom of the ramp, and that would be the difference between x initial and x final. So that's the length of the ramp. And so x initial we know is 0, so we plug in 0. Velocity initial is given to us is 5 meters per second. We plug that in. We calculated time, so that's 3.5 seconds. We plug in 3.5 seconds, and it's plus 1/2 acceleration times time squared. The acceleration is the same as before. It's 9.8 sine of 10. Sine of 10 because it's 10 degrees. And then time squared, which we plug in time again, we get 3.5 squared. And so once we calculate all of that, we get 7.07 meters. And so that's the length of the ramp, because that's the difference between x final and x initial from where she started to where she ended. So that's the length of the ramp. And so the length of the ramp is 7.07 meters, and it takes her 3.5 seconds to reach the bottom of the ramp. So that is the explanation. And this relates to what we're learning in physics recently, because we're focusing on kinematics, and this involves using kinematics equations and formulas to determine how long it takes her to get down the ramp and the length of the ramp, which is all kinematics. Thank you.